We'll be talking about just having tests inside the client to make sure that we're able to have some level of communications going. Then we discuss what it means to actually have interact between clients and how that would be orchestrated. Right. So down from the level of discovery, then the level of TCP/IP, and all the handshaking, connection, compression, all those elements, to how we'll see if we need to specify an application protocol so that we can exchange bytes in an orderly fashion. We segue from that into the lifecycle of domain objects. So those will actually define the interactions we want to see on the network. And the lifecycle of those domain objects will be bound to the core consensus algorithms, of course, which is being defined and worked on. So all this tied together, we need to be able to define different elements that can be tested at different levels, depending on the requirements. And definitely, the requirements stemming from here will come and affect this. Right? So we want to be really thinking about a way that goes like this, not pick a solution for transport and then have to rethink it 6 months later.
Cool. So that's a major priority, is now that we have this release, to begin to get all of the test vector formats and test vector generators so that clients can begin consuming these test vectors and know that they're actually implementing the same protocol. In parallel, we're going to be focusing on more clearly specifying the portions that fall into more of the networking side of things, explicitly defining the wire protocol. I'm going to take a stab at defining this API in the next few days, share it with everyone, debate it a little bit, and then we can start tying bytes and let's do it. And again, in this parallel, like kind of networking and testing, obviously networking, we're going to be testing that stuff too. But once you obviously come to consensus with yourself when you build a client, because it implements the same protocol. So once we have these minimal networking protocol defined, then I imagine client test nets, kind of transient test nets, like where I spin up clients, I have them talk to each other within my own client, are become possible and interesting. We're going to see some cool experiments here, but only when we have this really solid cross-client testing are we going to see interop. That's kind of the plan. There's a lot going on in there. We're actively talking with Felix to flesh out the discovery protocol. Hopefully we have some more documentation to share and get feedback on relatively soon. I know there's actually like a wire protocol and a more detailed spec than the EIP currently that's floating around that people are iterating on. Oh, and one more thing, and I've talked to you all about it, and I have some notes about it. There's a validator document, and the validator document right now specifies what the validator should do really with respect to the consensus, like what messages they need to be signing and how they're packing these things together. We're going to add some notes on the network topology, like where am I expected to broadcast, like if I produce a block, I should send it to the beacon, tag it with the beacon topic, pass it to the beacon chain, the beacon net. Whereas if I assign match to station, I should be broadcasting it to one of these shard subnets to be aggregated and then placed into the beacon chain. Anyway, those kind of network directive notes I'm going to add to the doc soon as well. So to recap, cross-client testing is incredibly important. There's a handful of people that are focusing on that, but if one person from each team really wants to take the charge on that and drive it, we need to have it driven. And networking stuff, it's time. Let's define it. Thanks.
The next discovery protocol probably should have some way of returning node metadata instead of just networking information like IP port info. So we were thinking something along the lines of being able to return Ethereum node records in the discovery protocol. And this will make it easier to find information about node capabilities, things like shards that they're a part of before even basically without having to leave the discovery protocol. And that will reduce network congestion and just make it easier to find information about nodes. The second thing we talked about was that there needs to be more work done around endpoint verification. So if you're familiar with DiskV4, we talked about this in the presentation. There's this process called bonding to validate that requests are coming from a valid node in the network, and it's imprecise and there are some problems with it, so we'll need to do more work around verifying valid endpoints on the network. And finally, we might want to explore options that are not Kademlia, because the fact is, whenever we talk about peer discovery, Kademlia inevitably comes up, but we know that there are problems with Kademlia, and so we might need to be more creative and think of something that's a little more unique and something that deviates from the original spec. So there's just more work and more research that needs to be done in that area. So like concrete suggestions moving forward, we think that we'd benefit from defining a more formal spec around the next generation of discovery. Everything that we saw, that we could find at least, was like scattered and mostly internal, unofficial. There's not too much documentation. The Go client has moved forward and implemented something that they call DiskV5, but the only way that you can learn about it is extrapolating from the code. So obviously we'd like to make things a little more official and get a little more consensus around what we mean when we talk about DiskV5 or just the next generation of discovery in general. Yeah, thanks.